Hello everyone. Welcome to my project presentation. I will be presenting my internship project on washing machine simulation using embedded system. My name is Indrani Panna and I am from the Department of Electronics and Telecommunication Engineering at Indian Institute of Engineering, Science and Technology, Shibpur. This project was done as part of my internship at Emertxe Information Technology. So, here's a quick overview of what I will be covering. Firstly, I will introduce the project and its purpose, what the project is about, what it aims to do. Then, we will dive into the theoretical background in system design, like some theory behind it. Then, after that, I will share the tools I used, the implementation process. What tools we used, what we observed, its benefits, advantages, disadvantages, limitations, and finally, our conclusion. Washing machine simulator. A brief introduction. Washing machines make our lives easier by cleaning clothes without much effort. In this project, we created a basic washing machine simulation using microcontroller called PIC16F877E. What's the purpose of the project? The main purpose of this project is to develop a washing machine simulator using embedded system. This simulator is going to perform the typical washing machine functions like washing, rinsing, spinning. Then, what exactly did we build? We created a virtual washing machine, a simulator. It lets user choose washing modes and water levels, just like in a real machine. We use tools like PiximLab, MPLab, XID, and embedded C programming. This system is designed for users who just want to load clothes, press a button, and let the machine do the work for saving time and efforts. We can see that we have used microcontroller PIC 16F7 F877A. So, what is microcontrollers? Microcontroller, we can say, are the tiny computers used in many devices like phones, laptops, and washing machines. They help repeat tasks automatically and accurately. After that, we have embedded system. Before diving deep, let's understand what an embedded system is. Embedded system combine hardware and software made for a specific task. In a simple manner, we can say we an embedded system is a combination of hardware and software designed for a specific task. We will find them everywhere, from microwave oven and washing machines to cameras and even robots. Okay, basis of embedded C language. So, for our project, we used embedded C to write the code. Why use embedded C, not other language? Simple, it's a general purpose language used in embedded software in OS development. Here are some key features of embedded C include it supports for the libraries, various number system like binary, hexadecimal and data types like integer and float. It supports if else condition, loops, like for, while, do while, and a modular coding structure, everything needed to control hardware and preciously. This slide shows the types of embedded system. There are different types of embedded system based on the performance and the functional requirement and based on performance of microcontroller. So based on the performance, there are four types of embedded system: standalone, real-time, network, mobile. In standalone embedded system, calculators are there. In real-time embedded system, fire alarms are there. In network embedded system, smart TVs are there. In mobile embedded system, smartphones are there. And on the basis of performance of microcontroller, there are three types of embedded system: small scale, medium scale, and sophisticated types of embedded system. So let's see about microcontroller versus microprocessor. Now let's understand the difference between microcontroller and microprocessor. So what are the key difference between them? So microcontroller is an integrated circuit which is capable of being programmed to be performed a specific task. In a simple manner, we can say microcontroller have everything in one chip: CPU, memory, ports. So they are easier to use for the small devices. So it has CPU, memory, input, output, ports inside the single chip. And it's compact and used for the specific task, like in our washing machines. On the other hand, microprocessor. Microprocessor needs external component and is a more flexible and more powerful than microcontrollers. But it's a more complex to design. Next is component of embedded system. This slide show the layout of our system. We can see that at the center is a PIC, microcontroller, and it connect to different components like memory, FPGA, human interface, ADC, DAC. So for our system, CLCD, character LCD for the display, buzzer for alerts, fan and digital keys for the input buttons are there. Next, let's talk about the PIC microcontroller. As we have seen that we have used PIC 16F877A microcontroller to build this project. So it's a very popular microcontroller from the microchip. It has a 40 pins. It has a 5 ports in total. In port A, there are 6 pins. In port B, port C, and port D, there are 8 pins. And in port E, there are 3 pins. It supports the serial communication, for it has a 2-pin transmitter and receiver, and it can also support the SPI protocol and works with the oscillator frequency from 4 MHz to 40 MHz, and it's powerful yet easy to use for simulation and real-time control task. To develop the simulator, we use some software which are MPLab XIDE. It's a development environment. MPLab XC8 compiler, Cross compiler, PixSimulate simulator. It's a simulating tool. So let's discuss in briefly MPLab XID. In MPLab XID, we wrote our code. So it's a special software made for the programming microchip microcontroller. So MPLab XID, it lets us write coding and debug our code easily. It also supports multiple tools so we can test everything in one place. So MPLab XID is for writing and managing code. Second one is MPLab XCAD compiler to compile our embedded C code. And third one is PiximLab simulator. So PiximLab simulator is a tool that helps us simulate our washing machine on the computer without real hardware. Next is the peripherals. So the peripherals we have used in our project is LED. As we have already known, the LED as a light emitting diode is a semiconductor device that emits light when an electric current passes through it. So LEDs light up when the current flows through them and they help so the status of machine like whether the cycle is on or off. They are connected to microcontroller ports, which act as a bridge between the code and the physical component. So LED are commonly used in the various applications, including indicators, display, illumination, and as a component in electronic systems due to their efficiency. Next is tactile switches as a digital keypad. So we use tactile switches as a digital keypad in a microcontroller. Switches are often used as input to control the operation of the device or to interact with the user. So these tactile switches act as a user input buttons. When pressed, these switches send the digital signal to the microcontroller, helping it detect user actions. So this way the machine knows when to start or stop based on button pressed. Next is the component used is CLCD. CLCD is a character liquid crystal display. So liquid crystal display is a flat panel display technology that uses liquid crystal to modulate light and display images or text. In simple, for the user interface, we use a CLCD, a character LED, a character LCD to display messages like washing started or cycle complete. So it uses multiple pins for the data and control and give a nice visual feedback to users. Next is we have a buzzer. The buzzer is a washing machine is used to keep in track of the washing cycle. We have used to give the audio alerts. For example, when the door open or when the cycle ends, the buzzer goes on for a few seconds to alert the user. So it rings when the door opens and it gives a 3-second beep once the while cycle completes. So it helps notify the users easily. So the buzzer alert activate when the door of the washing machine is opened and which is represented by the clicking the RBO button. So let's go for the demo. For the demo, we will open MPLab XID. We open MPLab XID. So in MPLab XID, we will write all the codes for our project. So in MPLab, we will create a new project for our washing machine simulator, but we have already made the project. So we directly open our project. We go to the file menu and select create a new project. After that, we will import all the header files and source file here. So in washing machine, we can see header files and source files. All the files has imported here. We have to import all the files. In header files, we will include files like CLCD, digital keypad.h, men.h, timers.h, washing machine header.h. And in source files, the source files are CLCD, digital keypad, ISR, main, timers, washing machine functions, and other codes files needed for the project has to be imported. So once all the files are imported and added and saved, then we will go to these are this is a main.c. We go to the build man project. We can see the message build successful. So the hex file has generated. So our hex file has generated. This will compile the code. Compilation is done and we have our hex file. So once all the build is successful, after after this, now let's open Pixim Lab to check if our project works properly or not. So before proceeding, we have to select the Pick Genius board. We can see here the Pick Genius board. We have to select, and in microcontroller option, we have to select PIC16F877A. After selecting, we have to load hex file. So we have our hex file here. MPLab projects, washing machine new.x, distribution default, production, then we will operate the board at 20 megahertz frequency. So on the screen we can see it shows press K5 to power on washing machine. So let's press K5. Now we can see the different washing program on the screen like daily, heavy, delicates. To go to the next option, press key 4. We have satin wash, eco cottons, woolens, bed sheets, rinse, press dry, dry wash, wash only, aqua straw. And back to daily again. We have to select a particular program and choose any option we need and long press the key 4. So we can see different water level options: auto, low, medium, high, max. We will go with max. So we can see now the screen shows press switch 5 to start and switch 6 to stop. Now let switch press switch 5. We can see the timer has started. The display shows function wash time, switch 5 to start and switch 6 to pause. And the timer is started and the fan has started spinning. Let's try pausing the cycle. We can see the display a warning message. The door is open, please close the door. So if the door is open, the warning message is generated. Once we fix that, the function starts again. To stop, press 6 and to start, switch press 5. When the program is complete, the buzzer will stop after 2 seconds and the screen will display program completed. Please remove your clothes. So as we can see program completed, please remove your clothes. After few seconds, the display return to washing program screen. So this is how our washing machine simulation works. So I have learned how to program and control hardware, how embedded systems are designed and tested, the value of automation using microcontroller in home devices. So this automatic washing machine simulator shows how embedded system makes everyday tasks easy and efficient. So it's a smart and time-saving way to do laundry, and this simulation gives us hands-on experience with real-world technology. So this was the overall demonstration of our project. Thank you.